Let's look at an example of how we would apply the inverse property of addition and the inverse property of multiplication when solving for a variable. So the goal is to get x by itself. So it's helpful sometimes to highlight what it is that we want to get by itself. So I want to get the x by itself. In this case, I see that x is on both sides of the equal sign. This is an equation. Since there is an equal sign, you have to have something on the left side and something on the right side. This equal is saying that the left side is exactly the same as the right side. So I notice I have a couple things happening to the x on this side. I have x being divided by 3, as well as a 4 being added to this x term. I have 2 times x on this side. So for most people, we want to get this fraction out of the way. So remember, and I'm going to just make a little notation over here, that x over 3 is the same as 1/3 times x. Okay? This x is in the numerator, this 3 is in the denominator. So x divided by 3 is the same exact thing as 1/3 times x. So let's not get confused by that. So let's think about which is the harder thing. Is division or multiplication harder than addition? It is. So let's get rid of that first. So we have to be careful. I want to turn this 3 in the denominator into a 1. So let's just look at this part right here. Let's just look at the 1/3. So if I have 1/3, what am I going to multiply it by in order to get a 1? So what am I going to multiply that by in order for this to become a 1? Because remember, we want this to be 1x. So I would use the inverse property of multiplication, which means the inverse of 1/3 is 3, or 3 over 1. Either way, it's the same. So I'm going to multiply a 3 to my x over 3, but with multiplication, it's like baking a cake. If I want 2 cakes, I have to double my recipe. I have to double everything in my recipe, which means that I also have to multiply my 4 by 3, because if I'm tripling this, I have to triple this, which means I also have to triple the other side, so everything stays balanced. So notice, if I'm going to get this out of the denominator, I'm going to multiply every single term by 3. So that means that I have 3 divided by 3. 3 divided by 3 turns into 1. So what I want you to think about is now this becomes a 1, which leaves me with 1x. So now I have 1x plus 12 is equal to 6x. So that's a much nicer looking problem. So problem is I have an x on the left and an x on the right. So I want my x to be positive. So I'm going to think, which one should I move? I'm going to move my smaller x over to my bigger x. So now I'm going to make this x turn into a 0. So 12, it's by itself. In other words, I have to use the inverse property of addition. So the inverse property of addition tells me I need to take the inverse of x, which would be minus x. Just remember, 1x and x mean the same thing. What I do to one side, I'm going to do to the other. If you feel more comfortable putting a 1 in front, you can do that. Doesn't make any difference. So notice that this on this side turns into a big 0. X minus x makes that a 0. So now we're left with 12 equals, well, if I have 6 x's and I take 1 x away, I now have 5x. So now I want to get x by itself. What's happening to the x? Well, 5 is being multiplied to the x. So if I want to get rid of this 5, I have to turn it into a 1 because multiplication's happening. So I'm going to use the inverse property of multiplication. So the inverse property means if I have the number 5, I want to multiply it by something in order for me to get 1. So if I multiply 5 by its inverse, I'll get 1. What is the inverse of 5? The inverse of 5 is 1/5. Now remember, this is the same thing as 5 divided by 5, because 5 times 1 is 5, and we just have a 5 in the bottom. You can think of this as over 1. 1 times 5 is 5. So that's why that becomes a 1. So if I want to turn this 5 into a 1, I'm going to divide it by itself. Could multiply by 1/5, but it's easier to just do division, which means what I do to one side, I do to the other. Since I only have one term here, I only divide by one term. But if I were to have 2 terms, I would have to do all my terms the same. So that means that 5 divided by 5, that turns into a 1, doesn't it? And there's nothing I can really do to simplify 12 divided by 5. I can't reduce that. So that means I'm left with x is equal to 12 divided by 5. I was able to isolate x, get it by itself. So let's just review some of the things that happened here. The first thing I did here was, this was the inverse property of multiplication. Then what did I do? I did the inverse property of addition. Then I did the inverse property of multiplication again. So you can see how our inverse property, it undoes things for us so that we can get the variable we want by itself.